All right, Higgs boson, take one. Hey guys, just want to talk about the Higgs boson. What is it? Why is it so important? And what's all the big fuss about it? So let's kind of get back down to the physics to understand what the Higgs boson is. Higgs boson is a particle that's kind of like the small of the small. It's smaller than atoms, smaller than quarks. A quark is a type of particle, but Higgs boson is another type of particle. So what does it do and why was it so important? The question really comes down to what is mass and how do you get mass in the first place? And as you know, mass is like how much you weigh. Like something that has like 100 pounds, that's a weight, but it actually has a mass to it to get 100 pounds. And a lot of questions were, why does something even have mass to begin with? Why does like a proton have more mass than the electron? What determines a particle's properties to give it mass? And to answer that, they proposed what's called the Higgs field. So in English, that basically means a field with a field that permeates the entire space as we know it, and it's composed of Higgs particles. And you can kind of think of these particles as like some molasses or glue, so that when another particle like proton or electron travels through that mass, it kind of gets stuck in that molasses, and those Higgs particles kind of run into it. And certain particles like a proton, which weighs more, has more attraction to a Higgs particle, whereas a lighter particle like an electron doesn't have as much Higgs attraction. And as a result, the more that something runs into a Higgs particle or is more slowed down by it, has more mass. So the whole big situation here is just the Higgs particle helps us explain what is mass. And you might say, okay, like how is that even important to me right now? Be honest, it's probably not like important exactly right now, but in the future it probably will be. It allows us to open up new applications. This is kind of typical of like what quantum mechanics did in the past, like in the 50s and stuff. We were starting to talk about it and we're like, what is this even going to do? How can we even use this? And no one knew at the time, but 60 years later, we're using it for quantum computing, for other different types of computers, and lots of other different electronics and synchronization techniques. So the whole point is that while this may not have application now, it probably will maybe come 50, 60 years from now. So maybe for your grandkids. All right, thanks guys.